Hello. Good afternoon, everybody in UK, and good morning for everybody in US and for the rest of the world. Have a good day. Welcome to our discussion on the machine learning topic, the advantages and challenges with the technology integration. As Adam said, I'm a data scientist from Chevron. I will try my best to moderate this session today. And we have a bunch of things that we would like to cover, and we have a lot of folks from other companies. And I will give the floor to Pedro to introduce himself, and then we can pass around.
Thanks, Mustafa. So my name is Pedro Santos. I'm a senior data scientist with TotalEnergies.
Harald?
Yes, so good afternoon, good morning. My name is Harald Wesenberg. I work for Equinor in Trondheim, where I work as a software innovator on the intersection between machine learning, blockchains, and the Internet of Things.
And Julian?
My name is Julian Zek. I am digital program manager for Maersk Drilling, working with maintenance optimization and utilization of data and information for maintenance transformation.
And finally, Brandon?
Hey, good afternoon. My name is Brendan Sullivan. I'm the Senior Vice President of Intelligent Edge Solutions at Viasat, which is part of RigNet, has recently joined. And I also am the Managing Director of Intelli, which is our AI platform out of Brazil that's on many of the deep water upstream assets.
Great. Thank you for the introductions. Well, we can jump in the first discussion point, the supervised and unsupervised machine learning, breaking down the applications of exploration and production. What type of applications of machine learning do you guys see, and can you tell if those are kind of picking up on supervised or unsupervised machine learning side? Who wants to?
I'll jump in first on this one.
Yeah.
I think we're actually past the point of supervised and unsupervised, and we're really in reinforced, and I'll explain that. But generally speaking, right, upstream energy has really exploded in digital transformation starting in 2018. So now 4 years later, we're starting to see some real results. I think most people, they just hooked up, data collectors to either their OPC or their WITSML data with these big data stores across all the subsystems. And really all they did was throw a lot of raw data and did unsupervised learning, right? A lot of math formulas to see if there's correlation. And then we got into a point with a lot of subject matter experts like we have on this panel, where we used subject matter experts to train the machines in supervised learning to, this is the prize, right? You're getting warmer, colder, and you train the machines to look for a certain insight, right? And that's supervised learning. I think we've gone from this just shining a light on dark data and getting pretty decent returns, just dashboarding, to pretty interesting sets of applications that are supervised learning. And then reinforced learning, where a lot of the digital twins and a lot of the software is now, it now knows the context. So it knows hydraulic models, it knows the engineering models, it's hooked to actuators, and it knows the actual physics. And so by adding in all that context, they can make much more intelligent decisions about what's going on and predictive maintenance and things like that. So we've now, in kind of the fourth year of this 5-year journey, have moved past supervised learning into reinforced learning, reading in all these state models. I know, in Intelli, we're up to about 68 different applications just for upstream drilling and completion. That's everything from, predicting stuck pipe, which is a very interesting predictive model. So predicting that you're about to get the pipe stuck about 13 hours before it happens, to everything from torque and drag and BOP monitoring and drilling basics and ROP optimization. We just launched a new thing which is called Dynamic Risk Advisor, which is basically the bow tie process of safety, and then implementing an action plan when you break a barrier, and then using sensor data to see if the action plan is actually working. So these circular real-time reinforced models are now live in the oil patch. I think mostly being used by by state-owned oil companies and super majors, but making its way down the mid-market.
Yeah, great points, Brandon. Julian, you want to go next?
Yes, so I would add on that what Brandon said. Since I work with asset integrity, and we are obliged to follow some rules when digitalizing or utilizing predictive maintenance or any other transformation of maintenance. So we started years back. We started with physical model. We started with deductive algorithms where we understand what we actually do, and then when we have understanding of the process and we have all these math formulas in place, then we started utilizing supervised methods to simplify our work and to make it more precise. Because if you are just following the physics, you will never be finished with all your equations. So from our perspective, as a technical perspective, supervised learning have much more value than unsupervised learning in the phase where we are now. So we have, of course, we have started and we did a lot of unsupervised clustering, but understanding what you're getting out was very, very small because of complexity.
Yes, I guess you touch an important point, and also supervised machine learning needs maybe a lot of training. If you have enough data to train, unsupervised learning, I guess, as you said, for clustering approaches, has been in the industry for a long time, especially in the downstream industry for anomaly detection, those kind of applications. Who wants to? Pedro?
Yeah, I can go next. Touching first on a point by Brandon, which is really important, which is that when you mentioned dashboarding goes a long way to start with, to get your foot in the door and show people that sometimes you just need to get all this information together to help decision making. But we moved on from that, and we've been doing a lot of supervised and unsupervised machine learning. So to give an idea of some of the applications that you both mentioned already, there is a strong focus now on emissions monitoring and reduction. So having some live forecasting on whether we are likely to exceed the targets or not. And there is a link between that and the machine performance and reliability. So we are building those links so that we know on a granular level how much we are emitting from each machine and how that is going throughout the day. So we've been doing a lot, as I said, on the machine reliability and performance, and it's been a mix of unsupervised and supervised. Unsupervised in the sense that we want to know whether an operating mode as a cluster is still happening at that moment, or if this machine is moving to another operating mode, and that's our unsupervised. And also, of course, we use that to train the models to understand whether we are going to move away from the desired performance, and we can start building some early warning notification systems that will tell you whether a machine is likely to trip or not. And we try to do it on the short term in the sense that you can start classifying whether a sensor is going to go haywire, but perhaps not leading to a trip. In other cases, you actually need an executive action when there is actually something that needs to be done immediately, and when you need to turn on another machine. And only in this scenario where you have a complete picture of what's happening and you have a notification, we can move to a world where we have single points of failure that are only possible if you have a machine learning model that is reliable, that the users use and trust. So we've been doing a lot of work on that in terms of having the users validate the results, so they are part of the process, so that we can tie that up as well in terms of the emissions. Of course, if we can meet power demands with a single machine, then we also reduce emissions. So it's all part of a big circle that just everything comes around.
That sounds good. Thank you, Pedro. And Harald?
Yeah, I think my fellow panelists made a lot of good points and have lots of good stories. I want to build on further on what Pedro was saying around this building trust with the end users, because we have also found that this is one of those crucial points where, because we have, as humans, we have a tendency to trust everything that looks good. And one of the things with machine learning is that it usually looks very good, but it might be difficult to understand what's going on behind the scenes. And so therefore we spent quite a lot of time on understanding what kind of domains that are suitable for machine learning. And in the exploration and production area, we found that it works very nicely for complicated problems, which means that complicated problems are problems where there is or complicated systems are systems where there is a predictability in response based on the input. But if it becomes a complex system where the response from the system becomes unpredictable, even given the input, then it becomes a lot more difficult to build this trust, because the users don't really understand what's going on inside the system. And so this collaboration with domain experts to truly understand the domain, to truly understand the problem, is where we've seen that we made a lot of good progress over the past years in understanding where we can use machine learning.
I think that's a really good point, and I think it's leading into a new trend, which is this human machine learning interface, where you're starting to see the next evolution. So what I mean by that for the audience is you typically, suck in 100 wells or whatever, and you train the state model using a lot of historical data, and then once you think you have a high accuracy rate, you then kind of upload that into the software, and you're doing it in real time, and you're testing against the state model. But what we've been trying to do is using simple things like having a chat window and creating a community of senior engineers. You can do things like thumbs up, thumbs down on false positives. You can interact with keywords. And what you're doing is you're using the subject matter experts to retrain the model in real time. Now, I know that sounds a little scary because these are big physics models and you don't want them to be wrong. But it's based on sucking in a lot of data, simultaneously. And then, you lock in it at certain accuracy levels. But by doing that, we're actually speeding up the way we can do supervised learning so much faster. And so there's a lot of experimentation going on about being able to constantly retrain the models to get to faster and faster to higher, accuracy rates and predictability. So, that's a big trend to watch in new platforms.
Yes, good points.
Can I also add another thing?
Yeah.
One of my favorite sayings, and I'm not claiming it's my original saying because I probably heard it somewhere, but many years ago, and that is that while applications age like fish, data age like wine. And that means that we spend a lot of time taking care of our data, because we see that the data is the foundation for all the machine learning that we're doing. And once you got the proper data foundations in place and the data products and everything, then it becomes a lot easier to rapidly build these applications that we're looking for, and build them small, build them fast, and then throw them out again if you don't need them anymore. But if you don't have that data foundation in place, you can have as fancy algorithms as you want to. And what we found is that is maybe often the most important barrier to where we are successful, and where we see the greatest potential is where do we have good data to build on.
Yes, this data is always a question mark. And as you guys mentioned, so sometimes we don't need very complicated models to get out of the data too. And trust is another thing, as you guys said. Hopefully, with machine learning evolving and is an ever-growing field, the oil and gas professionals need to trust machine learning days ahead. So I guess we need to go to the second discussion point due to time. The second is that the impact of machine learning in the oil field on augmenting business efficiencies and aligning people and process. So what type of business efficiencies you gain with utilizing those machine learning models, or what type of applications that you see most of the business had efficiency from?
Yeah, maybe I can start with this one.
Yeah.
I would say that apart from the type of problems that we're trying to solve for our users, aligning the processes, to me, the more important part here is to give the users the tools that they need in the format that they need. I'll give an example. When we have built some models for, let's say, if we build a model to do an early warning notification, a game changer perhaps is not going to be so much the results of the model being sent to some screens in a control room. Perhaps the game changer here will be to deliver these results in mobile devices, for example. That could be a game changer when we are able to put this offshore. So I would say that it is incredibly important to align people to what they need, but also to deliver things in the shape that it will be more useful to them. You can imagine offshore, it will be a huge facilitator and a huge game changer to have people doing their rounds. If they go with a notepad taking notes and then they have to come back and put that, for example, into a spreadsheet, that's incredibly frustrating. And if we solve these issues, and they can immediately input their data, could even be a validation of a model result saying, look, this sensor is wrong, can you go and check? They go in and check and they put it in a mobile device that will then reinforce the model results, the model retraining. That's incredibly important. I mean, we could try to build the shiniest of the models, but if we don't align to the way they work and we make it easier, it will just sit on another screen.
Great point, Pedro. Brandon, it looks like you have something to say.
Yeah, so we really, we kind of changed our marketing a bit and really coined the term operational AI, because the type of AI we're trying to do, particularly in upstream in exploration, is not only trying to improve the automation of an autonomous process, but then also improve the cycle time of the human process, right? And that's where you get the really big transformative, savings, right, and operational savings. And so, what's interesting about exploration is when you're just kind of doing, a reservoir yield model, that's a lot of math modeling. There's not a lot of human operation in that, right? When you're trying to do something like the autonomous drilling and you're trying to, increase your rate of penetration and your tripping time, and there's a lot of human crews in there, we can use the combination of machine learning and all the sensor data to, help them do decision augmentation and shorten the cycle time. So in real-time operations part of our platform, we roll everything up to really this RI, which is non-productive time, right? Or hidden time that you're squeezing out of the process by constantly tuning it, in real time, as opposed to, analyzing process in a lab. And then 6 months later, here's your new set of instructions to train the crew on. And we're seeing, if we average the bigger operators to just 20 active rigs, we're seeing them, in last year, they on average improved their MPT by about 0.5%, and that was about $500 million in operational savings, right? So that's $1 billion problem on, when you have, that many active rigs going on. And so there's been really big breakthroughs in being able to do these complicated processes, right? You got to be in an industry where they're expensive and complicated and semi-autonomous, and there's a few other industries, but particularly energy, the cost is so high, particularly offshore, that the savings are so high, and we've seen tremendous savings in lots and lots of use cases over the last 2 years in improving the operational time and the reduction of non-production time. And that's literally, showing up as the break-even point in getting a barrel of oil out of the ground is dropping precipitously. And it's because of machine learning over these operational processes.
Great. So it's great to see a small increase in efficiency causes results in a lot of cash flow.
Yeah. I mean, the minor ones, they just add up to a huge number quick.
Yeah. Who wants to take next? Julian, you want?
I would say that the problem of aligning analytics and the results of analytics with the processes, especially processes on board. We have like 20 rigs now in operation. Is the second biggest, maybe the biggest. I would not say that it's a bigger problem than data quality, but it is the next thing which need to be met, because we have a number of the systems on the rig installed through the time which are not used at all, and they are good. They are good standalone devices and system and analytics systems, but they are not integrated with, for example, with the maintenance management system. They are not triggering system, and they are not decisive enough to tell what exactly need to be executed. Because we don't have data scientists on board. We have people who expect to be instructed, okay, this is what you need to do. And that is the most important thing, because any other analytics, they can be perfect, but they will not be used in the field environment. And connecting these two things, we find very challenging. And there are several things, because there is, for the first thing is that there is very low faith of the crews and the people outside in this type of solutions. And that is because there is a lot of mysticism. There is no understanding what really machine learning is and what does it does.
Mm-hmm.
And if we go front to them that, okay, this is decision tree, or this is like random forest or neural network or something, they will even more back down on this. So providing the solution have to incorporate existing process and the change of that existing process and executable action. Just by proving that this works is the best way to get buy-in, to develop it further and get, of course, investment, because the money is coming from the operations to the development, not other way for us.
Yeah, go ahead, Harald.
Yeah. I think what Julian was saying, and also what has been talked about before, is that we have to make sure that we understand that these machine learning systems, they are part of there is a link here between the users and the technology. So when you develop the solutions, you cannot only have one set of skills in your team. You need to have multiple skill sets, and it's easy to think of the data scientists, the software engineers, and so on and so on. But what we've found is that you need to have like human factors and user experience capabilities in the teams as well, so that you design a solution that supports the human in the process and not something that confuses the human in the process.
Yeah, I totally agree. I think that the tech is getting ahead of the change management of the process, right? I was talking to a chief architect, and we rolled out a new app recently, and he said, I think it'll save us about $60 million a year, but we think it'll take 2 years before our operations will actually pay attention to the alarms and execute the action plan, right? Because they're very set in their ways and have been trained for 10 years. And so we're going to have to, prove to them, hey, this alarm acted and you ignored it, and then retrain them, and it'll take us a full, couple of years before we think we get the full value out of this. And we think it's probably 95% accurate. And I thought that was a really telling, mature statement from a customer about just how hard it is to change the culture of your operations group that have operated in a certain mode for a long time.
And also, I think we have to acknowledge that as technologists, we've been trying to push new golden hammers on all kinds of fastening problems for decades as well. So it's not unnatural that we are met with a bit of skepticism, because they have heard these stories that will revolutionize their world before, and so therefore we have to build, like we were talking about before, we have to build this trust and show this quality and show that the solution actually does and actually performs the way the users expect the application or solution to do.
Yes. We come to trust again here in this topic. That is an important piece of the puzzle, I guess. The next topic is on extending the life cycle, about asset performance management. So I guess we have a lot of life extension possibilities for existing assets for OPEX, and I would like to hear from you guys.
I could start on this one, maybe. Yeah. The thing is, there is a big, what we see and what we have experienced is there is a big difference what we think we can do with analytics and how much value that really produces, especially in the area of asset performance management or asset management. We can have a very good solutions which provides very good predictions and results, but when we look into the implementation, when we look into the whole picture, including logistics, including planning, including spare parts, including consumables, it may be that in the end, scheduling based on calendar or based on some kind of physical models is more effective. Not because machine learning is bad, it is just that offshore environment have its own challenges. And if you, let's say, can save 10 or 12 hours by predicting something versus actually consolidating work into the batches, because you have logistical organization which work in that way, it may be that doing it based on some kind of other kind of model is better. But on other side, for diagnostics, for fixing things or for estimating likelihood of failure, we see huge improvements in using machine learning, especially for the very old assets, because we can daily investigate their signature and extend work for them for a day, for a week, or something like that.
Yes.
If I could build up on that, the way I see this in terms of kind of the maturity of ML in the energy sector is that we've done a lot of descriptive stuff, so the dashboarding. We've done a lot of predictive already, so showing the users what is more likely to happen. I think that the next step, and that's where we are trying to do more work now, is on the prescriptive part, which is knowing that this is the most likely future for your asset. How can you now take your actions? How can we apply a prescription to this so that you are going to affect that future? And that feature could be that you are going to effectively extend your life cycle by taking these actions. I think this is a critical point. And also this links with something else, which is, I think it's very, very important to separate what are the things that you want to automate and the things you want to advise on. And because there are many gains on automating processes and bringing disparate data sources together and joining all these data sets and getting something into a dashboard. But there are also cases where, because of the degree of uncertainty, the best we can do is to advise a certain course of action, which then the users will validate whether that is possible or not. So in that sense, I think, again, coming back to the users, if we bring the users to the process and we work with them to build these prescriptive models, I think we can gain a lot in, as data scientists, in understanding really what are the issues that the users are facing, and how we can help them somehow automate this prescriptive process. How can we advise them on what will be the best course of action?
Yeah, I agree with both of you guys completely. I think the ability to predict a component failure is getting much better, right? There's a lot of algorithms of, you see this surge in heat versus throughput, and this electrical component's about to blow, or this antenna's about to fail. But that's not translating very easily into, okay, go and do these 5 things before you, and avoid the downtime, and therefore you get the big savings to extend the life of the asset. I think it has a lot of potential. I think, Julian, you had mentioned earlier, you got to really hook it into the maintenance systems and the ticketing systems to know that history of that and the repair logs. It's a lot easier to do on land than it is to do offshore because of all the logistical challenges of sparing and all that, right? And getting people out to those vessels. On the land market, it's in like fracking, it's a lot more straightforward, right? Like, they used to have in directional drilling maybe 70 segments. Now they're up to like 88, and some of these pressure vans might break down at like 80. And so, it's swapping out, that whole system right at the end of the job is quite expensive, right? So if you can just extend it enough, tell the crew to, not over pressurize this or not drive this beyond its spec, and report to management that they're over driving this, you can start to get some pretty quick savings, just get through the job so that you can do some maintenance during, between jobs. And then, there's lots of interesting conversations, especially with all the stacking that went on during the last downturn of the double black swan event, where, a lot of these are required to, bring a rig in for 5-year maintenance. Well, shouldn't we really be looking at wear and tear on the engine or engine hours like you do with like a personal boat? And then think about that. You could save a ton of money in your maintenance practices. So I think the potential's there, and the ability to predict failure has gone up quite a bit, but I don't think it's translated yet into, real savings that is the dream of, all the digital twins. Yeah. It's getting there.
Yeah, and I agree with you. Yeah. I agree with you, Brandon. And we have like condition-based maintenance on all rigs. Maersk have gone away from 5-yearly intervals for years ago. But the thing is, moving from A to B it have to be a very controlled process, because environment, we are not Facebook that if we just implement the algorithm and it fails, it's okay. It's not okay. We are dealing with high risk assets.
Okay.
Yeah, and I think I agree with Julian. You have to, because there is so much risk in play here when you're dealing with hydrocarbons under pressure. So you have to move slowly and make sure that everything you do is of sufficient quality and that you truly understand both the potential upsides and downsides of any new technology or new technology implementation. And this is where I think a lot of the discussions are ongoing. How do we build these dependable systems that we truly understand how they work, not just at the data scientist level, but also at the user level, so that we know that the users know when the system is not right, because that's an important thing for the users, because we know there is a long tail of problems that you will have with any systems, and the users have to learn to recognize when the system is not performing, and that can be quite challenging with some of these machine learning models, because there is like a limited understanding of it in the first place, and then it becomes difficult to know when it's really not doing its thing.
Yeah. Especially during production, I guess it's such a complex system. It's not like drilling a hole and get the oil out of it. So there are reservoir dynamics, there's production issues, topside, so all those equipments, leakages,
But on the other hand, I think when you have a existing installation and production, then you have a lot more data, you have a lot more visibility into your reservoir, into your asset than when you're drilling, because in the drilling you can see just a bit further than the drill head, and you don't really know what's going on there, and so in production maybe you have more visibility, and that gives you more complexity. But on the other hand, in drilling you have less visibility, but that makes it more unpredictable.
Yes. Okay. It was a great discussion. I guess we can move to the next topic, which is an ongoing, discussion, ever-growing discussion, machine learning versus deep learning, an analysis of capabilities and processes. So how deep we need to go in our machine learning model? Do we need complex models? Maybe a simple model. I guess we touched this a little bit in the first discussion, but I guess it depends. And whoever wants to take now.
Yeah, I can start here.
Pedro?
To be honest,
Yeah.
I tend to avoid using the word AI and all the acronyms that come with it. And I just try to use the expression the data-driven decision making. That's way more helpful, I think, because sometimes AI is just a regression model, simple one, and it gives you the output that you need, gives you all the explanation that you need, and it's highly easy to communicate with the users. So I think we need to be careful when we speak about deep learning, because you see it is just an extension of what we already do. So of course it is incredibly helpful when you start dealing with other sources of data that are not just numerical data, like if you start looking into images, and so it's incredibly helpful and you need these tools. I'll just put a caveat there that we need to be careful not to optimize too early, and sometimes delay deploying something to the users that will save them a lot of time and money, just because you want to get a really nice and complex model there when a simple one will do exactly the same or even better.
Yeah, I think you need to really have a good definition of deep learning. I agree. There's a lot of kind of buzzwords, right? Predictive analytics, machine learning, deep learning. I mean, deep learning is another form of machine learning. Kind of in my head, I have a certain feel for what I think is what people are talking about when they market, the phrase, my platform is really deep learning. I find that it's, I find it more useful actually in other verticals to understand. The classic example is, where I think it's GE predicts or Watson can, read so many medical journals about cancer treatments, right? And using deep learning, it can give you, nice treatment options that, no doctor can read that many, scientific studies at all times, right? And that seems to me to be a good application of deep learning to help with decision augmentation. I see less successful models like that, I guess, in oil and gas. Maybe it's because each oil field's very different when you get into the details. Each operator and their processes are very different, so there tends to be a lot of bespoke stuff based on a common set of principles. And so it's hard to just apply this massive deep learning over the industry over the last 10 years and say, aha, you guys should do this. I think there is definitely, some really interesting deep learning use cases. I generally pay attention to more outside of oil and gas than inside of them.
Yes.
There is an interesting thing with Watson, since you brought up Watson, and there was a study, I think it was in Denmark last year, where they were saying that yes, Watson can give really good treatment opportunities or options in a lot of cases, but it also kills a lot of patients. If you were to give it the prescriptions or the treatment that Watson prescribes, it would actually kill the patient. So Watson would kill more patients than the doctor, and I think this illustrates some of the problems with deep learning, and that is that any decision is kind of a two-part thing. One of them is a prediction of what is going to happen given what I'm doing. The other one is a judgment of all the predictions to see what they're doing, or to see what is the best one of the predictions and actions that belong to it. And I think the technology developments has enabled us to do predictions a lot better. We're getting better and better at predictions. That's what machine learning can do for us. It can predict all kinds of stuff, but we're still we're still lacking this judgment ability. And if you have come across what's his name, Judea Pearl's ladder of causality, where he talks about how machine learning and AI can see, and it can to a limited degree act, but it doesn't have this imagination, this counterfactual look at the world that makes humans such an important piece of the process here. And I think that's also where we see that that we can make a lot of progress in balancing these two. So the machine can help to generate more predictions, but you still need the human in the loop to follow through with the judgment before you make decisions.
Yeah, I think that I agree with both Harald and Brandon here. It is about controlling all of this. It is about controlling all these processes. Because I feel we still in oil and gas don't have good enough control of simple machine learning methods. That we can jump into the deep learning. We have, of course, tested, especially recurrent neural networks, multi-layered and stuff, but the results were not much better than simple predictions, which we could done in different ways. It was a lot of complexity, but in the end, the results were the same. And that was probably, I don't say that we see a huge potential in advanced analytics, but I don't think that we are still ready for that, because we are trying to treat it in a way how advanced analytics or deep learning doesn't like it, and because we are asking open-ended questions, but the results we are getting are categorical values which maybe are not the answers on our questions. So I think we will come there, but still we need to get an overview and control of all these simpler methods which we are implementing now.
Yeah. I mean, it's like the old axiom, right? Correlation. Oh, sorry. I was going to say, correlation doesn't equal causality, right? And so deep learning can give you a lot of correlation, but without a lot of intuition and subject matter expertise and oversight in these super risky and complicated models, it's kind of hard to really, apply it and get its value in a fully autonomous way.
Yeah, one last thing, Harald.
Yeah, but I mean, let's not make it sound like we're down talking machine learning, because machine learning has a lot of powerful properties in its speed, its accuracy, and its scalability. And if you manage to express your problems in a way that makes it easier to solve using these three properties, then it can be an incredibly powerful tool in your toolbox for the end users.
Yes. Traditional machine learning, seriously, I guess, will be utilized within any industry. But also there's a lot of room for deep learning too, especially during exploration. And we have acquired a lot of seismic data, fault detection. There are a lot of nice tools, apps that the exploration teams are building actually using deep learning. It's not like which one, but it's probably a combination of both of them, I guess, for the data science purposes. We have one more question. We have one more topic to cover, but I guess we have 10 minutes left too. And we would like to see if we have any questions from the audience at this point. If not, we can just continue discussion a little bit. Yeah, so far we have discussed supervised versus unsupervised machine learning and the impact of machine learning in the oil field. We touch base on the life cycle extension. Now, finally, we talk about machine learning versus deep learning, both of their capabilities and the processes. If anybody has any question in this period, please go ahead and ask. I guess we will see the questions soon in our chat box here. And I don't think we can wait forever, but Let's see if we have any question, then we can jump in. So the last thing is about what have you learned about implementing machine learning within the upstream sector. So this is upstream only. Who wants to give it a shot?
Maybe I'll start here. I think what I'm seeing is twofold. One is we are solving problems that are known to the users, and that goes a really long way when we manage to give them what they couldn't get before, but they knew about it. Like it could be bringing data together and showing them in a common front end. That's incredibly helpful for them. But also, we are allowing them to see things that they didn't know that they could see with machine learning. And I'm talking, for example, cases where we're able to build virtual flow metering systems for wells that they didn't have a multi-phase flow meter, and we couldn't get a real time picture of what's happening in that well or in that group of wells, and that has been incredibly helpful for them. So I think I've learned that once you solve the problems that are known, then you buy the room to to go after the other ones, because then you start getting their trust that we can actually give them something that is useful, that can save time and dollars.
Yes.
I'll jump in here. Just picking up on Harold's point, machine learning is now pretty pervasive in oil and gas, right? I think the first fog I spoke at, it was a lot of trial and error and a lot of experimentation, even though the idea has been around forever, since the 50s, right? And the computers finally caught up, around 2010. It's now, the 2015 downturn was a big catalyst. Now, at least the larger operators and the larger drilling contractors, they're using it throughout their operations. It's no longer in an experimental phase. We're seeing, repeated, platforms being installed, and then they just keep adding, more apps to new parts of the process and parts of the value stream. And they're getting, incredible results, right? You're seeing lots of different press releases on people doing sustainability and lowering emissions. And I read a really interesting article the other day about trial in the North Sea on that. You're seeing, our real-time operating centers where, they're not having to fly the 25-year experts out to every job site to do some analysis based on their experience, and that's yielding huge savings. So, I think it's been an exciting journey. We're still in the early innings, but it's very pervasive through oil and gas, right? There was definitely no doubt, 2017, 2018, there was a lot of promises and a lot of kind of snake oil being sold. And so it's taken a while for IT and operations to collaborate and really build something they believe in, and it's going in the right direction. I think there's now, at least in the top end of the market, there's CEO initiatives and a lot of weight behind these programs because they're yielding results. So it's just amazing to see what has happened in upstream energy over the last 4 or 5 years when it comes to machine learning and real-time platforms. And so, I want to leave on a real positive note. It's not speculative anymore. The question, what we do see though is, it's that dashboard thing. People throw out a dashboard. They don't really know what they're looking for. They get some really good results. And then if they're not really organized about the next set of questions or the next thing they're going to go after in a very systematic way, their program kind of stalls out. And then you get, management asking why they're spending so much money. And so we definitely see this kind of hump where you kind of start it and then it stalls out and then it goes mainstream within your operations. And then it gets really interesting and takes off. So I still think there's a lot of companies that need to go through that gap, if you will, right? That technological innovation gap. Some companies are beyond it, and they're just going to take off from here. But so it's a very interesting time.
Yeah, we have 5 minutes left, gentlemen. So Harald, do you wanted to say something? Maybe.
No. Do you have any questions for us, or otherwise? I have some thoughts.
Yeah, we don't have any questions left. But for the last question, discussion topic, you guys, Harald, Julian, you want to talk?
Yeah.
what we have learned about in Optimisation. Yeah.
Go first, Harald, please.
Yeah, no, I think building on what Brandon was saying, because I think we've seen a lot of I don't know what you want to call it, foundational stuff being put in place over the past 4 or 5 years, and getting kind of the basics right, and that means that we have successfully maybe digitalized and supported existing processes. But what I think is the exciting opportunities that are ahead of us is this ability to do to more transformative work, where you're actually thinking in software and really utilizing what the software can truly do for you, because of what software is not human, and getting that right is very very exciting in my mind. And also that means that one of the things that we're doing is that we're deploying our data scientists, our software engineers, our human factors experts into the operational environments. So we're sending the developers, the data scientists offshore to sit with the users, to generate ideas, to generate opportunities, and to see how that truly can transform the way that we run our current operations.
Yeah, go ahead, Julian. Yeah.
Yeah, and I just want to say for them that it is a very remarkable tool. Data-driven analytics and predictive maintenance are a remarkable tool. And working with this for the last 10 years, we have done, Brandon was mentioning it, we have done numbers of trials in Texas on the land rigs. And these trials were long-term trials over 1 year. And on the different rigs, we were able to save between 30 and 70% of maintenance costs over 1 year. But the problem with this, it was a trial environment. You had a team of rig user, of data scientists or software engineer, and technical support subject matter expert working together year long. It was extremely expensive. And we have full control on what is done, how it is done, and how data are handled and transferred to us. So in that environment, it was working perfectly. There was just only, I think we ran it on the 3 different rigs over 1 year. There was one failure which went through, and we detected it. We warned the rig 16 hours before, but they didn't want to listen. And it failed.
Mm-hmm.
But the thing is, it was a very good tool, but again, it required the whole ecosystem work together.
Great. Thanks, gentlemen, for your discussion today. We have almost a minute left. I guess the key takeaways I just wrote down is about having, first of all, it is essential to have a clear objective of the problem that we have, and along with the skills from both data science and subject matter expertise is crucial. Another thing is, I guess, we touched base about trust issue. ML AI area is ever growing in not only in this oil and gas, but from other industries too. And there are a lot of efforts coming from different industries and academia. Oil and gas, I guess, professionals need to believe in and trust in the future, and we need to think that there will be always unknowns in ML and AI, that we cannot sometimes fix things with the data science or machine learning. It is, because it's constantly evolving. Thank you very much, everybody. Thank you for a great talk.
Thanks.
Okay, goodbye.
Thank you.